Welcome to my screencast on understanding topic 2, current electricity. First of all, we've dealt with static electricity, which we now know is the discharge of electrons thanks to what we know about the law of static electricity. It's usually discharge from an object that's highly negative, which has extra electrons unnecessarily, to something that might be positive or even neutral. Now we want to deal with something different, or slightly different, and that is a steady flow of electrons, usually involving a conductor like a metal. For something to create current electricity, we have to have what's called a circuit. And there are two criteria for a circuit to happen which would allow the flow of electrons. You need some sort of energy source, which could be portable power, which is in the form of a battery, or it could be from a generator with direct current or alternating current, which we'll look at later on in the unit. And then there must be a complete path for the electrons to flow. It can't be open where there's a gap in the flow of electrons. If it is a complete path, we call that a closed circuit. So here's a really simple diagram of a circuit. We have a wire and a light bulb, and electrons leave the negative end of the battery. They flow through the conductor, through the bulb, which is a load, and to the positive end of the battery. And the electrons migrate this way, and we call that an electrical circuit. Here's some different things that might be in a circuit, keeping in mind that the fourth one's usually optional. So we need a source, we need a conductor, which is usually a metal wire, and we need a load. So let's look at my diagram. As I said before, these E stands for electrons. They go down, out the negative part of the battery, along the wire, which is usually copper, because copper is a good conductor, through the load, like a light bulb, and then back to the positive end of the battery. And although optional, sometimes we can have a control which will open and shut off the flow of electrons, or we can close the circuit so that the electron flow occurs in this direction. Electricians have a special set of pictures that they use when they're drawing electrical circuits, and so we need to be familiar with these pictures or symbols so that we can interpret circuit diagrams. So the first symbol I want to show you is this. This is the symbol they use to represent a cell, or if there's more than one, then it's a battery. So the long line represents the positive end of the battery and the short line the negative. If there's more than one electrochemical cell, then we would add more long and short lines. So this one you see here would be basically, in real life, it would be one cell and then a second one right here hooked up like this. So two. In everyday life, we call this a battery, but really in electricity, from a physics perspective, this would be, one would be a cell, and when we combine more than one, like this, now we would call it, technically, now it would be called a battery. Also, when you look at this picture, in normal everyday circumstances, usually each electrochemical cell is 1.5 volts. So if you had a plus and a minus, that's 1.5, and then another long line, which is the plus and a minus, this would be a combination of 3 volts. This next symbol is called an ammeter, which helps measure electrical current. This would be a symbol for a voltmeter. These two types of meters we'll deal with a little later on, next lesson, but they're hooked up differently when you put them into an electrical circuit. The voltmeter is hooked up in what we call parallel, and the ammeter would be hooked up directly as part of the circuit, which would be in series. So be careful when you're drawing these meters and hooking them up. This is a resistor, something that slows the electricity down, and then if we put a little dash like that, it would be a variable resistor. We already dealt with the battery symbol, and these represent light bulbs, which is a type of load. So here's an example. Let's look at this picture here. So we have a 1.5 volt cell, remember, not a battery, 1.5 volt cell, and a load, which is a lamp or bulb. And here's what the diagram would look like. Notice we don't draw curvy lines. It is important that you always draw lines that are straight like this, not curved. And so that would be the correct symbol. This is the plus part of the cell, and there's the minus. There's our lamp, which represents that. Here's another circuit. This time, though, we have 3 volts or 2 cells together making a battery, making sure your pluses and minuses point in the right direction that way. And yeah. Okay, let's see if we can draw a circuit diagram for what this picture looks like. Let's do the cell first. So the electrochemical cell, one long line to represent the plus and one short line to represent the minus. Straight lines now as best I can on this. And now I need a lamp. There we go, a little harder with my pen. Straight lines, and then I need a control, in this case a switch, and I go back up to the positive end. A little sloppy, but it's hard with the pen I'm at, and so that's what this one would look like. And then if you want, right now the circuit is open, you draw with the switch down and the circuit would be closed. Let's see if we can do a harder one, a 6-volt battery with 2 switches that control one light. And one of the two switches has to be a variable resistor or something called a rheostat, which those are the dimmer switch lights where you can dial the light brighter or dimmer depending. Okay, let's start with the battery. So 6 volts, that's 1.5. Another 1.5. So we've got 3. We got to keep going. There we go. There's a plus there and a minus. So 1.5, 3, 4.5, 6. There's a 6 volts. And we need 2 switches. Let's do our first switch here. And we'll put it up a little bit so it's open. And we need a light or a bulb. Let's put it here and a little loop there. And let's add a second switch, but this time it's a variable switch, a rheostat. So it looks like this, like that. And let me draw my circle around my bulb. And that's what this circuit diagram would look like. So you can dial this. This represents a variable resistor, so you could make kind of like a volume switch, a volume control on a radio. You could adjust this to control and slow down the flow of electrons. So let's look at switches. Here's our normal switch that we might see in a household, and you can see right now when it's tilted this way there's a gap there, but when you push it down, chunk, these two metals touch and electricity flows. And so basically you're joining the contacts together to get the current to flow. So this is what it looks like in your house. Again, when this comes this way, the contacts are touching the metal contacts. And here's our dimmer switch, which we call a variable resistor. And here's a picture of what it might look like, a variable resistor, kind of coiled wire. And if you slide this over, you make it longer, which slows down the flow of electrons, making this light go dimmer. If you move the wire closer and make the contact right here, electrons have shorter distance to flow, and that would make the light brighter. So that's how this works. It's also called a rheostat. Another name for it is, of course, a rheostat, a dimmer switch, controlling how far the electrons have to travel. Okay, volume buttons also operate under similar principles. And let's watch a quick brain pop clip about how all this works. Circuits.
Hey, don't stay plugged in too long. Mom said our electric bill was really nuts last month. Dear Tim and Moby, what is an electric circuit made of? From Joseph P. A circuit is a way of routing electricity along a path. Electricity happens when electrons, the negatively charged particles in an atom, move from one place to another. Electricity is nearly instant in the natural world. Think of a bolt of lightning or when you get a shock from touching someone. Right, those are examples of static electricity, sort of an uncontrolled burst of energy. It's actually not all that useful as a power source because all the energy is released all at once. Ow. In order for electricity to be useful, we need a steady flow of it, a current. An electric current doesn't just happen on its own. It needs a path to follow. And that's what a circuit is, a path that a current can flow along. Well, yeah, but you need more than just a wire. Even the most basic circuit is made up of a few different components. First, there's a power source, like an outlet in the wall or a battery. The power source provides a steady supply of electrons. In the battery, the electrons come from the negative terminal. From a wall outlet, electrons come from the shorter of the two slots, called the hot slot. The electrons need a path made of a good conductor, which is any material that allows electrons to move through it easily. Most metals make good conductors, so we use metal wires as path in electric circuits. Yeah, the wires are surrounded by rubber or plastic because those materials are good insulators. Insulators are kind of the opposite of conductors. They're materials that electrons have a hard time flowing through. Insulated wires keep electrons on course, and they protect us from the dangerous flow of electricity going through their metal cores. Along the circuit's path, there's usually a load, a device that uses electricity. Electrons flow through the device, giving it power. When they flow out of the device, they head towards the opposite side of the power source. In a battery, that's the positive terminal. In a wall outlet, that's the taller of the two slots, the neutral slot. And that's the real